Good morning, my name is Wasif Khan and today I'm going to represent Cackering by comparing Zermelo's recurrence theorem and Boltzmann age theorem. The idea of recurrence was first given by Nietzsche, and the quote, "For this time is infinite, but the things in the time, the concrete bodies, are finite." And this would happen one day that a man will be born just like me, and a woman will be born just like Mary. Was given by Heinrich Heine, a famous mathematician. Now, coming to the coarse graining, it is the description of the system regards large subcomponents. Phase space. Phase space refers to the plotting of both a particle movement and position on a two-dimensional graph, tracking of n particles in a two-dimensional space. Now, coming to simple harmonic motion. Here it is really interesting. It's a type of periodic motion where the restoring force is directly proportional to displacement and acts in the direction opposite to that of displacement. Yeah. So simple harmonic motion, x is distance, which is equal to cos omega t. V is the velocity, which is differentiation of x, and then acceleration is the differentiation of velocity, which will give us the final value minus the omega square cos omega t. So here comes the question, how would a phase state plot of simple harmonic look like? As you can see, I have drawn a pendulum and it will move back and forth, and I have taken velocity on the y-axis and the position on x-axis. So on every point on the graph is the state of pendulum or simple harmonic motion. Coming to Poincare recurrence theorem. Poincare recurrence theorem states that a certain system will after a long but finite time recur to a state very close to its original state. The Poincare recurrence is the length of time elapsed until the recurrence. The Poincare recurrence theorem implies the phase space would be closed until the evolution of this system. By illustrations, I have drawn a closed diagram. Now, coming to second law of thermodynamics. The second law of thermodynamics claims the system will move in the direction which maximizes entropy. As I have shown a graph P2 on y-axis and P1 on x-axis, an I point moves from I to F, which is V is equal to E power x, which is not a closed diagram. Moving on to the Keck ring. What would be the phase space of Keck ring? So I have drawn a ring on which I have marked some points, after which color changes of the black ball, which will rotate clockwise. So I have drawn our graph, V on the y-axis and P on the x-axis, and 1 represent black ball and -1 represent white ball. And when we plot the graph, it is recurring. So we have illustrated recurrence. We have to show irreversibility using entropy functions and using a geometric sequence. Because we are much familiar with entropy, so I will proceed with entropy as I have written omega is equal to n factorial over b factorial y factorial and made a Keck ring making position and points and a ball, and I would proceed h is equal to k log omega and k log omega n factorial divided by b factorial w factorial. Putting k is equal to 1 will give us log n factorial b factorial y factorial. Moving on. Yeah. Sorry. The p is equal to b n and q is equal to Wn, where B is equal to Pn and W is equal to Qn. Okay. So moving on, S is equal to log n factorial over Pn factorial and Qn factorial is equal to log n factorial minus log n factorial minus log Pn factorial. So here comes natural log n minus q n natural log qn minus p natural log pn. So we will split up this equation by the logarithm functions. Yeah, as n natural log n minus q n natural log q minus q n natural log n minus p n natural log p minus p n natural log n, where is equal to n natural log n minus q n natural log q minus p n natural log p minus n natural log n p plus q, where p plus q is equal to 1 as its probability. So n natural log n minus q natural log q minus p natural log p minus n natural log n, which will be cutted by n natural log n. So moving on, minus n p natural log p plus q natural log q. So S is equal to minus n p natural log p plus 1 minus natural log 1 minus p. So ds over dp is equal to 0. So we can move on. Minus n bracket p into 1 over p plus natural log p plus 1 minus p over 1 minus p into minus 1 plus natural log 1 minus p into minus 1 bracket closed is equal to 0. So it will give us 1 plus natural log p minus 1 minus natural log 1 minus p is equal to 0. So comes to the position natural log p over 1 minus p is equal to 0, which is implied p over 1 minus p is equal to e raised to power 0, which is equal to 1. So p is equal to 1 minus p, where 2p is equal to 1 and p has the probability of half. Now coming to the conclusions. The second law of thermodynamics holds whenever we shift to probabilistic model, whenever we shift to probability. Poincare recurrence theorem holds that we stick to a mechanical model, then it appears to be the case a system moves irreversibly. Whenever probabilistic model is implied and a system moves recursively, whenever a mechanical model is used, recurrence always holds for a mechanical model, and Boltzmann law always holds for a probabilistic model. So we have to ask ourselves the following question: whether our reality is probabilistic in nature or mechanical in nature, and then we could finally answer the question that Poincare recurrence theorem will prevail or Boltzmann's second law of thermodynamics would prevail.